Hey students, how are you doing today? I hope you're doing well, and I hope your Chapter 4 test went as well as you planned for and that you worked for. I've been very impressed with the work that you guys have done so far, and I hope that you've enjoyed these video lessons so far. So we're starting a new chapter today. So let's make Elliot little and take a look at what we're going to do this chapter. Whoop. So, Chapter 5. Chapter 5 is a very thick chapter, so we're actually going to break up Chapter 5 into two halves, Chapter 5A and Chapter 5B. Chapter 5A is going to be broken into three parts. First one, we're first going to start doing some exponential equations. Exponential equations are equations that typically look like, I usually think of them as a times b to the x. We're going to do it a lot more complicated than this, but this is kind of your typical looking exponential equation. Then we're going to spend, this is going to be about a week talking about the equation and the graph, kind of like how we did with the parent functions in the previous chapter. Then we're going to get into properties of functions, things like a to the m times b to the m equals, wait, I screwed this up. No, I said it right. Oh, I'm making mistakes. A to the m times b to the m would be the same as ab to the m like this, but I think the rule I was thinking of was backwards. I was thinking more of the lines of like x squared times x cubed equaling x to the 5, or like x squared to the 3rd power equaling x to the 6. Taking problems like that and simplifying, but a lot more difficult than this. That's just the intro. And then also we're going to be simplifying some roots, doing like the cube root of 370 or 354 x to the 5 y to the 9. Simplifying complicated roots. We're going to spend some time with that. And then actually then at the end of the chapter, we're going to get back into exponential equations and do some story problems. Now a couple notes about this chapter just while I'm thinking about it. One, calculator. I bugged you guys about a calculator at the beginning of the year, but I actually haven't held you to that, being like, oh, you must use this calculator. That's going to change with this chapter, because the minute we start doing roots, you cannot use a lot of those calculators that I told you that you can't use. You won't be able to use them starting then. Which is the friendly reminder, this is the calculator I'd love for you to get. I'll be doing all of my examples using this calculator starting today, the TI-30X2S. It's a good calculator. Second thing, the test for this chapter is November 10. That is the day before a 3-day weekend that I have for you. So I just want you to know that if you plan on not being here November 10, get the absence excused, and when you come back and you take the makeup test, you're going to be taking a more difficult test than your classmates. So in my opinion, it is in your best interest to be in attendance on November 10th. Okay, let's get into our lesson. We're starting off with exponential equations in Chapter 5A, and we cannot understand exponential equations without spending a day doing geometric sequences. Now, I gave you guys an investigation when you took the test to work on, and I asked you to do that investigation before doing this video. So if you have not yet done the investigation, stop the video, do the investigation, and then come on back. If you do not have a copy of the investigation, I have a copy of it on my website. You can find it there. If you did do the investigation, let's go over some answers, shall we? I'm going to start off with the side that had the graphing, the side of the investigation that looked like this. And these were my answers, and oh man, this worksheet was complicated. But I got that 1 was graph, wait, no, not graph, was equation. Oh, so these were the numbers, these were the equations, and then these were the graphs. So number 1 matched up with equation B, which was graph 4. 2 matched up with equation C, which was graph 6. 3 was F with 3. 4 was D with 5. 5 was A with 2. And 6 was E with a 1. I want to just the ones that I circled here, I'd like to take a minute just looking at a little bit further. What was interesting about 1 and 5 was those were the two problems that started with 8. And if I look for the graphs, it was graph, let's see, it was graph 4 and graph 2. These were the two graphs that started with 8. And then I noticed that one of these graphs was linear and one of the graphs was not linear. So then if I start looking up here at the equations that started with 8, that was A and B, and one of them I was subtracting 2 to get from number to number, and one I was multiplying by 0.5, which is the same as 1/2. There's a 2 in there. Anyway, the subtracting by 2, that causes a linear line, kind of like we discovered when we were doing chapter 3. And then the multiplier, when you get a multiplier to get from number to number to number, you end up with a graph that looks something like this. And then this graph would be a decay because you're multiplying and the graph's getting smaller and smaller and smaller. So I thought that was a good comparison between the differences between 1 and 5, giving you a linear versus more of an exponential model. And then as I looked through the graphs, my graphs for 4, 6, and 3, 4, 6, and 3. These were the 3 graphs that were all nonlinear. Nonlinear, nonlinear, nonlinear. And those 3 graphs went with B, C, and F. And if we look at B, you were multiplying. What else did I say? C. And C you were multiplying to get from number to number to number. And an F you are multiplying to get from number to number to number. So when you multiply to get from your first term to your second term to your third term, the graph will end up being a non-linear graph. And that's important to note. And we'll talk about the type of graph in future lessons. When I flipped the investigation to the other side, these were the answers I got for the first one. So the first question is the sequence arithmetic, geometric, or neither? Arithmetic, as you remember, that's adding to get from number to number to number. Geometric is multiplying to get from number to number to number. Neither would be some kind of random combination, maybe adding and multiplying or multiplying and adding. Who knows? But in this particular case, what you have is a geometric situation. And I know that because if I were to go 100 times 0.45, I would get 45. And then if I went 45 times that exact same multiplier of 0.45, I get 20.25. So it's geometric, and I was multiplying by 0.45. At growth or decay, the numbers are getting smaller, so it's a decay. Oh, how do you know? That's because the numbers are getting smaller. Part B, what's the pattern? We already talked about the pattern when we did Part A, but it's important to note that this is called, whatever you multiply by to get from number to number to number, that is called the common ratio, not the multiplying thing. Common ratio. And then finally, the recursive formula. Well, we've done recursive formulas before. This one started with U0, which was 100. Then to get from number to number to number, they multiplied by 0.45, with n being greater than or equal to 1. You're going to see a common theme. In geometric sequences, we almost always start with U0. Do we start with U0 every time? No, but most of the time, at least with the way that we're going to be writing these problems. And then finally, number 2. So if you were paying, if account was paying a 7% interest, well, that's, you know, so you're getting the 100% that you already have plus a 7% interest. So what you're really getting every single month is 107%, which if you change that to a decimal would be 1.07. So I went 2,000 times 1.07, I got 2140. Then I went 2140 times 1.07, and I got that number. And you can get these numbers really quick with your calculator if you just simply type in the first number, so 2000 times 1.07, I get that 2140, and then when I go times 1.07 again, it says answer times 1.07, and then at that time, then all I have to do is hit enter, and it gives me the next month, enter, next month, enter, 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 and just hitting enter allows me to fill up all of these numbers. So that's part B. Part D, the recursive formula, well, like I mentioned, we're starting with 2000, and to get from number to number to number, we're multiplying by 1.07. Then finally, when will the account double? Well, that's just using, using the calculator and just doing enter a bunch of times. So if I go 2000 times 1.07, I get that. So that's 2140, that's 1. So times 1.07, that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I hit the amount, when I hit the calculator 11th time. So it would be, let's see, annually, that's years, so 11 years. Is there an algebraic correct way to do that? Yes, and that's the point of this unit. All right, so that was just the investigation, just going over the investigation. I'm already at 12 minutes, and that's kind of long for just going over this investigation. So I'm actually going to stop this now, and I'm going to do part 2 of the lesson in a couple minutes for the lesson half of this. So I'll talk to you soon. Bye-bye.